Since it was made available to citizens in 1983, GPS has been used in many applications, including in the entertainment industry, to provide precise timing for synchronized playback and position information to allow an event to occur when a person or vehicle reaches a certain location. Q-Sys allows users with a GPS receiver that can communicate via serial to take advantage of this information by processing the data in one of two ways, and today I want to give you some ideas on how you can use that data. The first thing we need is to actually have a GPS unit connected to our core. In my case, I have a Core 8 Flex with the GPS module connected to serial port A and its pulse per second output connected to GPIO pin 1. I'm using a Garmin GPS 18X LVC, though any GPS module with an RS-232 serial connection and a 1 Hz or 5 Hz pulse per second output will work. The GPS module will also need to be configured to output the RMC message in order for the core's internal logic to process the data. This is also a good time to mention that if you have one of the server-based cores, like a 610, an X10, or an X20R, the built-in processing logic and precision timing won't work for you, and you'll need an external PTP source if you want that precise timing. But if you only care about position data or rough timing, you can still use a serial adapter like the QIO S4 to get the serial data into the core. In order to demonstrate GPS usage, I have 3 demos today. So the first one looks at precision timing and using the internal GPS processing in the core. So in order to do this, we go to the core status block and we set the clock source to GPIO in pin 1. Make sure the clock type and baud rate are correct, and we'll go ahead and send this to our core. You'll notice I also have the GPS info component. This will show us all of the data that comes out of our GPS as it's been processed. And I have a loop player, a meter, and a text controller that I've called loop player controller. If we look at the GPS info block, you can see we have the status, we have our time and date, we have latitude and longitude, though I'm keeping that under wraps, as well as speed, course, and the number of satellites the GPS currently sees. Now I want to talk a little bit more about the loop player. The loop player is a very powerful playback engine for precisely timed playback when you need synchronization with other devices. So if, for example, you have a few different cores that all have their own internal playback and you need them to play simultaneously, whether they're linked via network, you can use PTP as a clock source for the loop player. You can have them linked via analog audio and use timecode as a clock source for the loop player, or you can have them connected wirelessly. If you have good GPS reception, you can use that as well. In this case, I have it set to GPS. I also only have the one channel set up, and I want to show you inside of here. You'll notice there's no buttons. There's not really any controls. There's a gain we can mess with, but that's about it. The loop player expects to get commands for playback from an external device. Whether that's a script, a plugin, or a QRC command, really anything will work as long as it can tell the loop player when to go. So this text controller here, I have the controls broken down here. I've got my file name already set. We'll go ahead and pick a start time of 22, we'll do 14:15. If I press Q, you can see the loop player has received the command. The start time is there, and when we get to 15, playback starts right on time. This is incredibly useful if you have, say, parade floats, and you need to synchronize audio between onboard and offboard systems, or if you have distributed cores, systems where you can't really get all the channels of playback you need between two endpoints. Anything like that would be useful here. If we go ahead and exit out of this demo, I'll bring up the second one, which is utilizing the GPS info block again. However, in this case, we're actually looking at the latitude, the longitude, and the course. So I've got 3 different text controllers here that are all set up. The first one uses a raycasting algorithm to determine if we're inside of a polygon. I've got these 4 points here. They're roughly square, rectangular-ish. And we would actually be able to determine whether or not we are inside these 4 points. I've got this great circle algorithm here. We have the center point as well as a radius, so we can determine if we are within some distance of a certain point. And lastly, I have the great circle, but also with heading calculation, so we can take a look at not only where we are, but also what direction we're going. Each of these can be used for whatever you want, whether it's trigger playback when you get to a certain location and you're facing a certain direction, or you just want to know if you're within a certain area. Anything like that is available with these. The last demonstration I have is coordinates, but in this case, we're using the serial port itself. This is useful for like the 610 or the X10 or X20 where you don't have a built-in serial port. You can use a QIO box as your serial, or if you don't want to use the GPS clocking, you can just pull the serial data directly, process it through here, and again, we've got our latitude, our longitude, and our angle. We've also got a few other things that we're not using here. I also have this data spoofer, which I'm using to generate test data, and a data selector so I can actually use that data while I'm working on my scripts. Before I go, 2 more points I do want to make. Number 1, if you have the serial port object in a design, make sure the core is not set to use GPS for clocking. The internal GPS processing and the serial port block will just sit there and fight with each other and nothing will work. And lastly, you'll notice that in this design, I'm actually working with the pulse per second signal through the GPIO. This doesn't work super well. There's a lot of timing errors that I'm seeing in PPS, or sometimes the 100 millisecond pulse will actually just be entirely missed. So I can't recommend processing the pulse per second signal if you care about highly accurate timing. Hey, Editing Kyle here. I noticed something while I was working on this video, and I just left the file running. The original script was written with 9.10, and now that I'm working with 9.13, this actually seems to be a lot more stable in terms of the pulse per second. There's still a few milliseconds of error, and I still wouldn't use anything highly precise against it, but it actually seems to be doing significantly better. As you can see from the numbers down at the bottom, it's supposed to be 100 millisecond on time and a 900 millisecond off time, and it's reasonably close. Certainly better than it was in 9.10. Anyway, back to the outro. And that's all there really is to it. I of course didn't talk about GPS antenna placement or signal issues or more complicated system setups, but this should give you enough information to at least get going with whatever project you want to work on that involves Q-Sys and GPS. I hope you learned something. Thanks for watching.